Okay, now recording. All right, so we're talking about the scope of a variable. So the scope of a variable is telling you where you can access the variable. So the variable can actually, be inaccessible at certain parts of the code. Are you okay? It's happening. So you put it in your mind. Don't try to understand it for now. Okay, so a variable scope is determined by where you declare it in the code. Are you okay? All right, when you declare a variable within the procedure is, for example, the odd and even determiner, for example, is a procedure. Okay, the maximum algorithm is a procedure. So you can have all this in one box. All right. Okay, so when you declare a variable within the procedure, only the code within the procedure can access or change the value of that variable. So in other words, if you go and write max inside the odd and even procedure, are you with me? Okay, so in computer program, we have something called a procedure. Are you okay? Or subroutine. Another name for a procedure is a subroutine. So the variables are available only within the particular, procedure that you've written. Is that all right? Okay, so it has local scope and it's procedure level variable. So let's take note of that. Once you talk about local scope, then we can also have global scope. Are you okay? All right. If you declare a variable outside the procedure, you make it recognizable to all the procedures in your script. So it means that there is a hierarchy, there's a structure. Are you okay? We will not understand this till we start actually writing. We write a lot of code. You appreciate it. Okay. So if you declare a variable, it can be only accessible within a certain local context, and it can also not be available at all. Is that okay? All right. So there you go. Someone is making noise. I think the person is out now. The lifetime of a variable depends on how long it exists. Is that okay? So the lifetime of a variable, the term is what depends on how long it exists. That is its lifetime. So variables can actually die. Are you okay? We can kill it. Are you okay? Even in computers, we can kill processes. So you can imagine that. That's a concept that exists in IT. So the lifetime of a script level variable extends from the time it is declared until the time the script is finished running. So that is why we can clear memory in computers. Sometimes you have a lot of things, the memory is actually taken up by the variables. Actually, that is the reason why even your phone, excuse me, you need to close the applications. If you don't, then all these there are a whole lot of memory usage by the variables that are actually running at runtime. During runtime, there's a lot of data that's being stored. Are you okay? All right. So the lifetime of a script level variable extends from the time it is declared until the time the script is finished running. Are you okay? Okay. So that is it for local and then global variables. And then of course, you talk about lifetime of variables. When the procedure, okay, let's look at this one. At procedure level, a variable exists only as long as you are in the procedure. Are you getting that? So that is also variable, and that is also possible, and it's relevant. It can be compared to, it relates very much to the scope. Are you okay? All right. So local scope variables also have a lifetime within that same. This is conceptual. So I think when we actually do the programming, you appreciate it more. When the procedure exists, the variable is destroyed. Are you okay? It is killed, so you can just destroy a variable so that it's not there anymore. That's because, you see, computers are actually running, and then their memories directly relate to the variable, okay, which is actually stores the values. So everything we are doing in computers, we are just using variables, memory, computer. So that's why if your memory gets full and there's no space, the computer will just crash. It won't work again. Local variables are ideal as temporary storage space when the procedure is executing. Okay. Local variables are ideal as temporary storage space when the procedure is executing. Okay. All right. You can have local variables of the same, name in several different procedures because, okay, so what it means is that when I write three procedures, all right, I can decide to, for example, use the word minimum, but then within different local, context. What does that mean? So I can, because within the different procedures, I have what we call local scope. And the lifetime is only within that scope, the beginning and end of that scope. Are you okay? Maybe you're not appreciated, but as we, you write more programs, as you try your hands, you understand what I'm talking about. So when you are given assignment, do it so that we can give you more assignments. All right, assigning values to variables. I think we should understand this is very easy. Values are assigned to variables, creating an expression as follows. Anyway, the variable is on the left side. I talked about this already, of the expression, and the value you want to assign to the variable is on the right. Okay, so this is the right to left assignments. Okay, it's done in a lot of, in fact, I don't know which programming language that doesn't do that. The right is being assigned to the left. Okay, so here b equal to 200 means that 200 is being given to b. It doesn't mean b is equal to 200 as you are thinking about it in mathematics. Are you okay? So, but then you see, algebra appreciate that more. In algebra, when you write y equal to 2, it means you are giving 2 to y, isn't it? All right. So y will become the value of 2, but really you don't have to think about it as an assignment because we can do other assignments. Speed 1 equal to 20. This is not a good variable name. The s here should be what? Smaller s. Okay, when you are naming variables, always use, so this one is better to write speed, okay, small letters. Even though it's good to have the 1 here so that the end equal to 20. Okay. All right. So there you go. So t equal to +1. This is a way of writing t equal to t +1. Like I said, this is the only place in programming. Yeah, this is the only place where we can actually, do, this cannot be possible in math class. When you're teaching children in primary school, you can't write this. They will tell you that you are wrong, isn't it? It's just like saying 1 is equal to 1 plus 1. You see, it's not possible. But that is why this is not an equal sign per se. This is actually an assignment operator, which is saying that take t, whatever value is in it at that time, add 1 to it and give it to t. Is that okay? All right. So I'm making use of these Zoom tools and I hope they don't mess me up. All right. So there we go. So this is possible only in programming. Please, if you don't understand, you let me know right now. If what I've just talked about right now, if you don't understand, don't let me move and go past it. That is what I was talking about earlier on. Okay, so I'll move on from there because you didn't ask any question. All right, much of the time you only want to assign a single value to a variable you have declared. Are you okay? So there's something called declaration of a variable. I've already talked about it. In other words, when you declare a variable, what you are saying to the computer is that it should create a space in memory where values will be stored. Okay, so we need to understand that we can declare a variable and then use it. But in some programming languages, you don't have to declare a variable. It will assume, I think in Python, for example, it will just know that since you are using a variable, whatever value you're giving it, then it will dimension it as such. So the dimensioning means we are using we want to store a particular type of data. Like I said, you want to store data, date, you want to store date, you want to store integers, you want to store floating numbers or real numbers. Are you okay? All right. So there we go. A variable containing a single value is a scalar variable. So there are two types of variables. You can have an array variable and a scalar variable. Okay, but then the scalar variable stores just one value. Okay, so a variable contains a single value is a scalar variable. All right, so an example of a variable is b here in this example. All right, so b, this is a variable. This one is a constant. Are you okay? Now this is, so this is a variable. So in algebra, that's, we have variables, we have constants. All right, so speed is a variable. So t is a variable, but this is not a variable. Are you okay? That is not a variable. This is a variable. So I'm actually kind of teaching some algebra here. Are you okay? All right. So let me get this right. Okay, so yep, a variable contains a single value. We call it a scalar variable. Other times, convenient to assign more than one related value. Yes, exactly. We're talking about array variables here. So you can decide to store so many variables or values, so many values in one variable. In that case, you have what we call the array variable, an array. In fact, array is an English word, and it actually stands for, a couple of objects that have been aligned. Are you okay? A list, for example, so it's kind of like an array-ish type of, object. So an array, to array something is in an array, that means it is actually arranged in a certain order. Okay, so you can create a variable that contains series of values. We call it an array variable. Array variables and scalar variables are declared in the same way. So there should be a way that you tell the computer that this variable is an array variable or a scalar variable. All right, except that the declaration of an array variable uses a parenthesis following the variable name. So if I actually write, where's my pen? So the dime statement, oh, what is this? So if I use the dime statement, it means I want to declare a variable. So dime t as integer. That means t will store integers. Are you okay? We are telling the computer create a space in memory to store values that are integers. Are you okay? All right. But when I'm actually dimension an array, then I have to do dime t. Okay. Then you have parentheses. Is that okay? When we put 2 here, it means I want to store 3 objects. Later we'll find out why it's like that. Is that okay? Because some programs, they have what we call zero indexing. That means that anything any counting that it does starts from 0. So 0, 1, 2. That means 3 objects are being stored. Are you okay? All right. So let's carry on. So array variables, single dimension array containing 11 elements. So if you want to store 11 things, dime a, so the variable name is a. Okay, so the variable name is what? Is a. All right, there you go. Although the number shown in the parentheses is 10, all arrays in VB script are 0 based. So this array actually contains 11 elements. That's what I just talked about. All right, so example, dimensional arrays contain 12 elements. So all of you, if you have a pen and paper, try it. Dimensional arrays contain 12 elements. Do it now. I know you don't have pen and paper. I know. So I won't even wait. Is that okay? I'll move on. So dime ARR1, maybe Juliet has it. 11 is okay because we want 12 elements. So 11. And the reason it's 11 is because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is actually 12 numbers, objects, count of 12. You assign data to each of the elements of the array using an index into the array. Is that okay? All right. So I can have, say countries in the world stored in an array, so that inside the array, the first one will be maybe Algeria, next one, or Libya, UK. Or so it's like a list. Are you okay? Now what it means that I can change the array elements. Is that okay? So this is more like some kind of vector. Are you okay? You can look at array like a vector. So maybe Algeria is here. Are you okay? Ghana is there. Okay, Nigeria is there. So so this is an array containing 3 elements. All right. So it's like some kind of vector. You can look at it that way. All right. You assign data. How do you assign data to an array? So example is what it means that we use the indexing. So if you have A0 and on the right hand side, the value there, then it means you are assigning 256 to the first index, the first position in the array. I hope you are following. Or don't be quiet, and then next week I give you assignments and you tell me that you don't get it. So A1, or maybe like Julia said, we get it now, but later on we will not get it. All right, so A1 is equal to 324 means that we are giving 234 to the second element, even though we are written 1 is the second object, because when you look at it, where are you? Okay, so I think I need to probably escape this card. Because of a statement we made here, VB scripts are 0 based. That's the reason why when you see 1 as an index, it means 2. When you see 3, it means 4. 0 is 1. Because of this 0 based, I don't know who came out with it. So just put it in your head. You don't have to wait too much about it. Dimension arrays contain, so we've done this already. We are going backwards. Okay, so now you can see that we can keep going on and on. Assign 100 to A2, which is actually the third element, up to say A10. That means we have an array of what? 11 elements. Are you okay? So when you see 10 to be the max, that means there are 11 elements in there. All right. So similarly, the data can be retrieved from any element using an index into the particular array element you want, for example. So here we can get from an array and we can set a value into the array. So here we are getting the 9th element in the array and we are storing it in a variable called some variable, okay, which has not been well named, okay. All right. So VB program to add 2 vectors of the same dimension is an example. So you want to add a 3x1 variable to a vector to a 3x1 vector. Okay, how do we get it? So we need to create 3 arrays. Why? We need 1 array to store the first vector, then another array to store the second vector, then a third array to store the sum addition of the 2 vectors. Got a 3x1 vector. Today I can't write with my finger on the whiteboard, so I wish I could do that. Let me try one more time and see. It's a shame that it doesn't work when you need it most. I'm only using my mouse and it doesn't help too much. Let's see. I don't know whether it's got something to do with your fingers. Let me dry my fingers and see. Let me actually dry it up a bit and see what happens. Screen, I don't know. Let's try it. Don't fail me. Yeah, I think it's working. So it's got something to do with the dryness of my fingers. Wow. Okay. All right, that's good. I'm happy that at least it's working. So you have a 3x1. Oops. Oh, there you go. I just send you. But I think it got something to do with my fingers. It's a touch screen which CAF bought for me. I wish CAF would buy a laptop for me. We are so stingy. Anyway, hey, I shouldn't be saying this. I'm recording this for YouTube. Anyway, I messed up already. Yes. Yeah, but that's the truth, isn't it? I think sometimes we need to face the truth. You not bought anything for me. I have to see it. So this for YouTube. Everybody hear me out. All right. So let me see. Okay, so let me see if I can. If I use my hand, I'm able to do it better. Maybe I should zoom in a bit. I don't know if that helps. Okay, maybe this will help. Oh no, it doesn't. Okay, so let me move on. Otherwise, I'll spend my whole life on this. All right, Microsoft Whiteboard. Something needs to improve on there. So 3x1 matrix. First, you have to, if you don't understand 3x1, don't try to understand what we are talking about. It's simple as that. So that's a theory program. You need to first understand the problem at hand. Maybe when they taught you vector, you never understood the idea. So you can't write a program for it. It's as simple as that. So a 3x1 matrix looks like this. 4, 3, 1. Another 3x1 will be like this. It will be -2, 1, 0. And then when I add it, this is how you add a matrix. 4 plus -2 is 2. 3 plus 1 is 4. The 1 plus 0 is 1. What is the program doing? You see, when you write a program, you make people stop doing this thing. They now use your program to do the addition of factors. That is the whole thing. So programming really brings about automation and then, optimal resource use so that we don't repeat the same or reinvent the wheel over and over again. So that is why, so because the question one of you will be asking is that, why are we even doing this when we know we can just do IOK? The reason they created the calculator is so that you don't have to be anytime you want to calculate, you are doing it the way, your primary school teacher taught you 210, then you put 111 here and then you draw a line and direct IOK. This is what programming is trying to avoid. So that, put that in your mind, it'll help you to appreciate what we are doing. So now we want to, what do we want to do? We want to write a program, that actually adds this up. Okay, so now we have to find a way to represent the first vector. Okay, I'm writing with the mouse, so please bear with me. The handwriting will be nice naturally. We want to add it to the second vector. So vector 2, and then we want to now obtain vector 3. Are you okay? So what we have to do is now store these, create an array variable for them. Is all right. So the first vector, vector 1, we have to dimension it. Are you okay? So we dimension, so v1. How many elements are going in there? 3 objects or 3 elements. So we dimension v1 that, okay, and we can choose to even dimension and give it a data type, so as integer, but for now let's leave it like this. We need to also dimension, so it's assumed that the user will be entering values for this. The second vector is v2, that will store the same number. Are you okay? So the first thing we do in programming is to actually dimension our variables, declare our variables, dimension it, declare it. Are you okay? Same thing. All right, so there we go. Now we want to actually assign values to vector 1. Okay, so we just do dim. No, actually we already dimensioned it, so we don't have to dim again. So now we can assess the value because we dimension it. So the first value is 0, given an index of 0, and then we can now put the value in there. Are you okay? So I'm just randomly, I'm not keeping the same values up there. So I'm giving new values. Second one will be what? Maybe 2. And then the last one will be, so v2, this is v2, this is v3, this should be index 2. Are you okay? So this is 1, this is 2, equal to, say, -1. Okay, and then what we want to do is that, guys, I think Zoom is not limiting us. We are doing limitless because I just created this recurring thing. So remind me when the time is up. Is that okay? And I'll go. All right. So we need to now store. Oh, look at me. So the mistake I'm making is that I'm changing the variable name. Are you okay? Here I'm storing for v1. So everything here has to be v1. Okay, so this has to be v1, this has to be v1, this has to be v1. So it's the same array, but different indexes are receiving different values. So v1, v1, v1. Then we do v2, v2, v2. Are you getting that? So v2, 0. The second vector, see, let's call this 5. v2, so this is 0. Okay. This is 1. Same v2. So let's store 20. The same v2. Then we have 2, the second element, equal to say 8. Are you okay? All right. So now we need to obtain v3. Okay. So here v3 is actually given by, okay, v3 0. Are you getting that? Okay. So let me just leave it. v3, the first index is 0. We want to set it to what? v1, the 0 index, the first element, which has 0 index. v2, the 0 index, that will give us v3, first element. v3, the first element. v1, first element, plus v2, the first element. Okay. Then finally, v3, the third element is actually given an index of what? 2, because of this we started from 0. Equal to v1, the third element, v2. Oh, sorry. Yeah, that's it. Exactly. 2. Yeah, the third element. And so now we have obtained, the sum, the addition of the 2 in the v3 array. So this is how arrays can be used. Are you okay? But obviously, there's a lot of automation. We don't have to write it like this. You can actually represent the indexes by what? By a variable, say I, as a count. Are you okay? You can set I to be the counter. So you can set I to be 0. And then instead of you writing 0, 1, 2, are you okay? You rather loop over it. Are you okay? You loop over it. You write one statement. All right. So you can write v3i equal to v1 I plus v2 I. So over I. So you go to the next I. Are you okay? Next I. So for I equal to 0. Actually, this is what you write to 10. So it means you're actually adding 10, but actually in this case, for I equal to 0 to 2. Are you okay? If you have 10 elements, then you do that. But here, 0 to 2. So this will actually take the values in the array v1 and then add them to values in array v2 and then give them to v3. So the first, when I is equal to 0, you have 0, 0, 0. Then it goes, rich here goes back up there. Are you okay? This is called the for next loop, which we talk about, but I think I've just talked about it. I'll touch on it again one more time for you to get it. It's all right. So if you go back to our PowerPoint. So dime equates, like I said, we are going about I'm repeating everything that I just talked about. The dimensioning is done. You assign the values. So here, there's an interesting thing happening here. We are trying to get the test property of the test, an object, okay, in this case, the test box object, and then we are assigning it to the first element in array number 1. Okay, so it's assumed that the user is entering the values into a text box. So I'm adding an interesting dimension to it. It's okay. Remember, we've already talked about getting the property of an object. That is what we are seeing over here. Okay, so here we are getting the property. Are you okay? We are getting the property, test property. All right, and then we assign it to the first element. Okay. All right, so we're doing the same thing for this one. For this one to do the same is okay. So we find a nice way to collect data from the user interface. Are you okay? Which contains a text box. So a text box is just an input box. It's just like an input box. It's not exactly an input box, but yeah, it allows you to make an input. It's like some box like this that you always see, and you enter a value into it. You see it in the calculator application as well. Okay, so if someone put in 20, and then this is the name of this test box. Every object has a name. Are you okay? So now I'm getting the test property of this box, and I'm assigning it to the array. So this is how this array gets filled. Array 1, array 2 also gets filled this way. Okay, so you have to name your variables in a way that makes sense. All right, and then now you can start adding the values like we did over there. So here we are taking the array 1, array 2, same indexes are added. All right, and so forth. Is that okay? All right, now this is synonymous to what you are seeing on the right hand side. Okay, so what you are seeing here is what we are doing over here. So the programmer should understand this, what happens here, and then apply. So we are adding this and that, AX plus BX. Okay. Before they start using the array to implement this. Okay. So that is that. If you have any question, you can ask. Don't be quiet, because the next moment I'm asking you to do something, as you always know. You have any question, you can ask. What time did we start this lecture? We started 5:40, 5:50 or something. Is it 4:50?
Yeah, 4:45.
4:50. 4:50. So yeah. So 5:50. We've done about an hour. We've done about 1 hour. Yeah. So we do some 15 minutes. And then we're good to go. But you need to ask questions. Don't just be there and then ask me a question later. This is the time that I'm ready to answer questions. Not tomorrow after I've eaten banku and okrusti. Okay. This is the best time when I'm in the mood to answer any question. Do you kind of get the idea at all? Do you get it? Do you kind of follow it to a point? Juliet.
Yes, sir.
Talk to me. When you are quiet, I think I like it, crowd. In any relationship, communication is key. Yeah, but you don't know. It's neither here nor there. If you get it, as if you don't. Which one is it?
Yeah, that's what I'm looking through it.
I taught this in class. This concept on the right hand side. I taught it in class. We spend a lot of time talking about this. Objects and their properties. I hope you, Juliet, remember that one.
Yes.
So that is what is happening here. But once you've gotten it, remember this is not an equal sign anymore. This is actually what? an assignment operator. So we are assigning this value to this. Now, since this is TST, blah, 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 it means that we are actually dealing with a text box. I'm telling you that we are trying to get data, data input from the user. Are you okay? So the 20 can be, WGS coordinates. Are you okay? That we are trying, the user is putting in. Is that all right?
Yeah.
Okay. Okay, so there we go. Someone says they are in a trust key, they can't unmute their thing anyway, because there's a lot of noise. The mate is collecting his money. All right, no problem. So do you get the idea of scalar and array variable? So this variable on this board right now, you can see that we have, this is one variable. This one is one. This is another. But they contain so many values. In fact, they contain 3 values. This contains 3 values. But the values can be accessed using an index. You okay? So hard, Mati. So you can access the values in the array by using the index. These are the index. Okay, 0. So every index normally, every index is in a certain sequential order. Is that not so? So we are using the zeros and stuff to, the 0, 1, 2 to assess the value. It's not the actual value in the thing. We are only using it to assess a value. So for example, if you want to know your results, which you are not getting, you not receive any results since you can, I don't know, we get your index number, and then the index number retrieves all your data. So that is the idea of an index. Every index, SNET takes your SNET number as an index to get your SNET contribution. So that is what is actually happening here. There's an object which contains so many things, but you need to tell me which of the objects in what level you want to retrieve. So you give me a number, you say 3, then I'll go to 3 and I bring it to you. Okay. It's as simple as that. Please do follow.
Yeah.
All right. Maybe, as you said, later on, go and do a discussion on it. This one, there are stuffs online everywhere. So you don't have to, if you don't understand what I'm talking about, you can just go and read it. But I think this is the best explanation you can ever get. All right, you can declare multiple dimensions up to 60 dimensions. What does it mean? It means we can do like an array, are you okay, that contains more dimensions than just one dimension. The one we did is one dimensional array. You can have a multi-dimensional array, like as if it's a matrix. Are you okay? But we can do up to 60 dimensions for Visual Basic. Is okay? All right. So we can do, this example is a multi-dimensional array, my table. So this one is like you have 5 rows and then 10 columns. Are you okay? Or actually 6 rows and then 11 columns. Okay. All right. So 6 rows and 11 columns. There you go. I didn't even look up, even written it here. Okay, so 6 rows, 11 columns, because 0 index, so 5 plus 1. Okay, 5 plus 1. 10 plus 1. That will give you that. Okay, plus 1 will give you that. Okay, because you are starting from 0. All right, remember that. You can also declare an array whose size changes during runtime. We have dynamic arrays. Okay, so we can also look at that. So a dynamic array will have to, it can change as you go, it changes the size. Okay, this one is very useful in programming because sometimes you can't predetermine what the array size will be. So you make it dynamic, all right, so that it can change according to the value that you have. For example, in the maximum algorithm, then you can actually set, maybe you don't know what the maximum number of values are going to be. So in that case, you do a dynamic array. And then you always have to call the readDym, okay, so that it changes the dimension for you. Is that okay? So here we don't specify any size. As you fill it, it bloats, and as you readDym it, it changes to the new size that you want, depending on what you have. So this is arrays. Okay, in fact, you have different types of variables. You have two types. You have the scalar variable and you have the array variable. And the array variable, you can have a multi-dimensional array, or you can have a one-dimensional array. So the one-dimensional is like a vector, and then the multi-dimensional is like a matrix. Are you okay? All right. So here we have a 6x11 matrix, RC. Yeah, row and column. That's how you define your array. All right. So we've done an example on that. Maybe I'll just introduce you to the next one that we close. We don't have time. Remember that the intention of the school is that we do an exam in January, and I'm going to have my lecture with you when I'll be in Kumasi. I think so. Where I'm going there for my Christmas. Okay, so we all have to spend our time. Let's not waste time, because whether you waste time or it doesn't help you. Your life doesn't get better if you slow down. So be up and do your things in time. Assignments that you are not doing, they will come back hunting you. All right, great. Okay, so there we go. If you don't have any question, we will talk about what we call access levels very quickly. Is that okay? I think, these, I don't need to even waste time on it. When you say public, it means that you are declaring a variable that will be available throughout your project. Are you okay? So anywhere in the project, anywhere, you can access that variable. Is that okay? So you can have public class. That means that you can access it from different projects. All right. All right. Then you can have, so the example, what you saw down there, this is the structure that I was talking about in programming. Normally you start, you declare something, this is the beginning, this is the end of it. This structure repeats through our programming process. You can have private. So private, if I declare something as private, it's available within the particular procedure normally. All right, or the same module. So you can do private x as integer. So the variable is x, the data type is integer. We touch on that again. Private is the access level, so where it can be accessed. All right. So remember we talked about access levels, procedure level, global level, variables, etc. You can look at protected keyword. Is that right? All right. Which elements can be accessed only from within the same class? All right, etc. So the access means I want to use it. If you don't want to use something, you don't try to access it, do you? All right. So that is the whole. Friend is also the protected friend keyword from the same assembly. Is all right. Protected friend, okay, protected friend keywords together in declaration. Specify the elements that can be accessed from within, from derived classes, etc. I mean, these are not things we should. But obviously, example of the structure, in programming, is what we are looking at. Here is a subroutine for a class. Are you okay? Right. So we can write so many subroutines or procedures for this. This particular procedure is what gets fired when you click a button. So everything that I write within this space will get fired. Everything I write here will get fired when I click the button 1. Are you okay? So some of these things are auto-generated. Remember, there's what we call the integrated development environment, which is a software. Like I told you to install Microsoft Express, and I hope you've all done it. Visual Studio Express. We're looking for Visual Basic. All right. We need to use that for practicals soon. But you are slowing the class down, so we are not getting there. But one day we'll get there. Anyway, so data types, it's very important to know that we can have, different types of data types. Okay, they store different values, and then they actually assign a certain memory allocation. When you store data as double, the values range between what you are seeing on the right. Single stores that, but normally double is like real number. Are you okay? You are storing a real number. So as you can see, there's a dot here, 4.9. You see, so the dot there makes it the real number. Integer, you see, is actually a whole number. So here we don't have any, you know, period sign. Okay. So points is not in there. String stores, you know, characters, a character of strings. Okay, 0 to approximately 2 billion Unicode characters. So they are different characters. You can have the Chinese type of characters. Okay, that one also is also there. Boolean stores true or false. Okay, so Boolean, if you want to check if 2 is greater than 1, someone has to keep it somewhere for you in the computer. Okay, so we have the logic. Yeah, all the logic in computers make use of the Boolean data type. So string is for storing something like your name. Are you okay? We'll give examples very soon. So double, like I said, is real numbers. Integer, whole numbers, negative and positive. Long is also like a large integer. Is that okay? So if you want to put a very large integer like the voting that we are doing, elections and all that, the values are very large, millions. You want to use a long, not an integer, because the limits are not the same. Is that okay? But I didn't put the long here, so I can't show you that now. All right, so we can have an example. Dime T a string. That means that store characters inside the computer. Are you okay? T. Are you okay? Create that space and then store values there. The variable T stores a string made up of characters make up a. So now you see that what is storing is CHARACT, not like the way you read it, but it's storing all that in that variable. All right, so we'll talk more about this in our next meeting. I don't know, Juliet, since I don't get feedback from you, I don't know how to teach you. You hardly talk. Are you overloaded? Should I continue? You are too quiet sometimes. Should I continue talking about this or we should break?
So please, let's break.
Yeah, let's do what? I didn't hear you.
Let's break, please.
Yes. So we'll end it here. Okay, but this is where we are ending at data types. So please understand data types. Is that okay? You can store dates, for example. Okay. All right. Space is an example of characters. So let's try to understand it. We will talk about operators in our next lecture. We will talk about operators. Is that okay? Mathematical operators, where we find out that plus, minus, division, okay, all those things are relevant in programming. Is all right. And then there's a way that it's done, and we evaluate expressions and see the final value of the expression. So read about it. I want to quickly leave here. I want to quickly finish this lecture. It's dragging. Anytime we miss a lecture, the lecture becomes boring. So guys, take note of that, and yeah, just take things seriously. Okay.